finds the general term an, given that a1 equals 1, an plus 1 equals 2an plus n times 1 plus 2 to the power of n equals 1, 2, 3, and so on. From here, we can see the relationship between an plus 1 and an, but we want to find the general term an. Now we divide both sides by 2 to the power of n plus 1, and we can now write n plus 1 over 2 to the power of n plus 1 equals an over 2 to the power of n plus n over 2 to the power of n plus 1 plus n over 2. 2an over 2 to the power of n plus 1 is an over 2 to the power of n times 1 over 2 to the power of n plus 1 is n over 2 to the power of n plus 1, n times 2 to the power of n over 2 to the power of n plus 1 is n over 2. We move an over 2 to the power of n to the left-hand side. We can now write an plus 1 over 2 to the power of n plus 1 minus an over 2 to the power of n equals n over 2 to the power of n plus 1 plus n over 2. This holds true for all n in the sets of positive integers. Now we sum this from k equals 1 to n. We know that sigma k equals 1 to n, k equals n times n plus 1 over 2. So sigma k equals 1 to n, k over 2 can be written as n times n plus 1 over 4. Many terms on the left-hand side cancel, so we can now write an plus 1 over 2 to the power of n plus 1 minus a1 over 2. We're given that a1 equals 1, so minus a1 over 2 is minus a half. We move minus a half to the right-hand side. Here we have 2 to the power of k plus 1, which can be written as 2 times 2 to the power of k. We can move a half outside of the sigma sign. Now we multiply by 2 to the power of n plus 1 to obtain an plus 1. Now we need to work out sigma k equals 1 to m, k over 2 to the power of k. We let Sn equal sigma k equals 1 to n, k over 2 to the power of k. So 2Sn equals sigma k equals 1 to m, k over 2 to the power of k minus 1. Sn can be written as 2Sn minus Sn. So Sn can be written as sigma k equals 1 to m, k over 2 to the power of k minus 1 minus sigma k equals 1 to m, k over 2 to the power of k. Sigma k equals 1 to m, k over 2 to the power of k can be written as sigma k equals 2 to n plus 1 k minus 1 over 2 to the power of k minus 1 sigma k equals 1 to n k over 2 to the power of k minus 1 can be written as 1 minus n plus 1 over 2 to the power of n plus sigma k equals 2 to n plus 1 k over 2 to the power of k minus 1. So Sn can be written as 1 minus n plus 1 over 2 to the power of n plus sigma k equals 2 to n plus 1 k over 2 to the power of k minus 1 minus k minus 1 over 2 to the power of k minus 1 k over 2 to the power of k minus 1 and minus k over 2 to the power of k minus 1 cancel. So this term can now be written as sigma k equals 2 to n plus 1 over 2 to the power of k minus 1, which can be written as sigma k equals 1 to n, 1 over 2 to the power of k, which can be written as a half sigma k equals 0 to n minus 1, 1 over 2 to the power of k. We know that sigma k equals 0 to n r to the power of k equals 1 minus r to the power of n plus 1 over 1 minus r. By applying this, sigma k equals 0 to n minus 1, 1 over 2 to the power of k can be written as 1 minus a half all to the power of n over 1 minus a half. 1 minus a half is a half in the denominator and a half here cancel. 1 plus 1 is 2 minus n plus 1 over 2 to the power of n minus a half all to the power of n is minus n plus 2 over 2 to the power of n. Now we substitute Sn here, and we can now write an plus 1 equals 2 to the power of n plus 1 times a half plus a half times 2 minus n plus 2 over 2 to the power of n plus n times n plus 1 over 4. Half plus a half times 2 is 3 over 2. A half times minus n plus 2 over 2 to the power of n is minus n plus 2 over 2 to the power of n plus 1. Now we've obtained an plus 1. To obtain an, we just write n instead of n plus 1. So an equals 2 to the power of n times 3 over 2 minus n plus 1 over 2 to the power of n plus n minus 1 times n over 4. 2 to the power of n times n minus 1 times n over 4 can be written as 2 to the power of n minus 2 times n squared minus n 2 to the power of n times 3 over 2 can be written as 2 to the power of n minus 2 times 6 2 to the power of n times minus n plus 1 over 2 to the power of n can be written as minus n minus 1. So this is the general term.